how do we understand our place in the universe? How do we try to answer the big questions in life? Who are we? What are we made of? Where do we come from? With the advent of digital age of computing, we were suddenly able to answer questions never before solved. Exploring the relationship between the imagination of the scientists and the frontier of computing and the ever closer reality of the universal quantum computer, this film examines the hazy boundary between imagination and reality.
So what I want to build is a large-scale quantum computer, a device which can solve certain problems so much faster, tremendously much faster. So what means much faster here? Much faster means that even the fastest classical computer may take 1 million years for a problem a quantum computer can solve in a few milliseconds. So that means we can solve problems which we never even thought of that would be solvable. You know, we may find new drugs, we may understand processes in biology, we may understand life itself. I grew up in Germany in a place called Ulm, close to Munich and Stuttgart. My mom would always say I'm asking a hole in her stomach because I kept on asking questions about everything. My father would take me to the planetarium and we would watch the shows, and I would go out in the evening with my telescope and try to learn about the planets and about nebulas and space in general. I watched Star Trek in primary school and I knew then I wanted to be science officer on the Enterprise. And then I did some research and tried to figure out what do I need to study to become science officer on the Enterprise. I realized that actually being on a spaceship is not so great, but understanding nature is actually pretty awesome. So and understanding how things work, the mysteries of quantum physics, in fact the mysteries of subatomic particles, of how the world works. What I really wanted to do is building something which can teleport somebody from A to B, building some kind of shield for a starship, building a starship engine or things like that. All these kind of things fascinated me. And so this is maybe the starting time of my scientific career, really. One of the things which is very strange is that you could be at two different places at the same time. So that doesn't mean there's two of you, it means you are at two different places at the same time. And so we actually make use of that, not with people but with individual atoms. And so we have them at two places at the same time. There's another very strange thing which is entanglement. And basically what that means is if you have two entangled particles, and you separate these two particles and put them on one end each of the universe. If you do something to one of these particles, then something will happen to the other particle, even though they don't communicate. And that's just very strange. It really is completely mind-boggling. And we actually trying to utilize such quantum effects to build a quantum computer. For a normal traditional computer, you write certain things into the memory, and then, for example, a number, and that number then goes through the processor, is computed, maybe multiplied with another number, and the output happens. Now imagine you could write all the numbers in the world simultaneously into your memory and compute simultaneously all the calculations you want to do and get all the results out at the same time. This is kind of how a quantum computer works. So what do you see here? This actually is a very rudimentary, extremely small quantum computer. So your classical computer operates basically with a memory, a hard drive, and on that hard drive you save information, and that information is saved in bits. And so the more information you want to save, the more bits you require. And so the same in a quantum computer, you want more and more bits. The more complicated the problems you want to solve, the more bits you need. But now you're not using bits, you use quantum bits. And quantum bits are encoded in each ion. So one ion is one quantum bit. And so inside a quantum computer, you have then tens, hundreds, thousands, even millions of individual atoms, and each atom is exactly one quantum bit. We trap ions using electric fields. So we hold a single atom using electric fields in a vacuum. And so using these electric fields, we can now control the location of the ion. We can shuttle it from one point to another point. And so the ions are now the bits, the quantum bits in fact, inside the quantum computer. Quantum computing can revolutionize the way we live. There's a lot of possibilities, and I think we only know a very few of them at this point in time. In the same way as classical computing, when the first classical computer was built, we barely scratched the surface of what computers could do, or what can computers do right now. And the same thing happens with quantum computing, that really we know very little of the opportunities quantum computers can provide us with.